Greetings. My name is Eric Juma Obwile. I am a GIS Biodiversity Ecosystems expert, and I'll be taking you through the procedure of calculating protected areas in the OECM's coverage. Remember, the headline indicator of Target 3 of the Kunming-Montreal Global Biodiversity Framework is a coverage of protected areas and OECMs. So we have a methodology that we use to calculate these statistics at a global level, but the same methodology can be used at a country level or even at a regional level. So I'll be taking you through that procedure, and the purpose of this session is to enable you to calculate the protected areas and OECM's coverage for your country. So if you are from a country and you are involved in the process of reporting towards the KMGBF to the CBD, then you can use this methodology to calculate the statistic. We are also addressing a concern from some of our stakeholders who actually approached us and told us that their value, their area, the area that they have calculated for the protected areas and the OECMs is different from the area that is displayed on the protected planet. So by going through this session, you should be able to calculate your own protected areas and OECM's coverage. Remember, in WDPA, and for most of the countries, their protected areas do overlap. And sometimes you get protected areas of different designations overlapping. For example, you can get a national park overlapping with a forest reserve, or you get a national site overlapping with an international site. So the methodology that we have has been designed to avoid double counting or double counting of protected areas. So a protected area will only be, the coverage of the protected area will only be used once. If there are overlapping protected areas, then that area is, the common area is what will be used. So allow me to go through the presentation. We are still on module 4, though this content can also go to module 3 on GIS for wildlife protection and conservation. And exactly what we're going to do is calculating protected area and OECM's coverage. So we have some factors to consider before you do this calculation. For example, the definition of protected area in the OECM is very important. So only those sites that meet the definition of a protected area in the OECMs are included in this calculation. So if there is a site which does not meet this definition, even if it was submitted to the protected planet, it cannot be used for calculating the coverage. And a good example is at the biosphere reserves. They are not used in the calculation because some parts of it, the buffer area of these biosphere reserves are not really protected areas. Only the core area is protected, and therefore only the core area is used. And for that core area of a biosphere reserve, it actually overlaps with the national protected area. So biosphere reserves are normally omitted in this calculation. Then the second factor that is considered is that not all protected areas and OECMs are used in the calculation. We have some of the protected areas which are omitted, and the reason why some are omitted, as much as these areas might meet the definition of protected and conserved areas, some of them are in the early stages of establishment. For example, all the proposed protected areas or OECMs are not included in the calculation of the coverage. And the third factor is the base map layer. The base map is used especially first on splitting protected areas that are on land and in the sea. Remember, the target 3 talks about conserving 30% of land and inland waters, and also the seascape. So the base map first is used for differentiating the terrestrial and marine protected areas or marine protected areas coverage. But also very importantly, base map is used to differentiate maybe regional and other coverage, or even continental coverage. But for the national coverage, what we use is we use a field called ISO 3 to only calculate the protected and conserved areas for that particular country. And lastly, we have a method. We use a spatial method in the calculation of this coverage. And when we are using spatial method, we do what we dissolve. So the protected areas of a country or a region or even a continent or global is dissolved to avoid double counting of area. But also very importantly, we use what we call a coordinate system to also improve accuracy of our calculation. For example, WCMC, which is also one of our partners, moved from using Molwade coordinate system to using WGS 1984 geodesic coordinate system to improve accuracy. WGS stands for World Geodetic System of 1984. It's a global coordinate system that is used widely for geodetic calculations. So those are the factors that are considered in the calculation of protected and OECM coverage. So I have already explained on the definition of protected areas and OECMs, and I told you that only those areas that meet the international IUCN and CBD definitions of either a protected area or OECM is included in the calculation of coverage statistics. I've also mentioned that some protected areas and OECMs may not be publicly available because of restrictions requested by data providers. These sites are not availed on WDPA, but they are used in calculation of statistics. Proposed protected areas or those whose status have not been reported are excluded from the calculation, and that is very important. Those protected areas whose status have not been reported are not used in the calculation of statistics. So recently, there is a requirement in the database that all sites that are updated must have a status. So we are in the process of verifying the sites that were added to the database before the policy was enacted. But for those sites which were added to the database before this policy and were not whose status were not reported are not included in the calculation of the statistics. Sites submitted as points with no reported area are also excluded. So if there is a site that was submitted but it doesn't have a reported area, it's excluded from the calculation of the statistics. Another thing that maybe we need to consider is that what I mentioned, UNESCO Man and Biosphere Reserves sites reported to the WDP are also excluded, and for the reason that buffer and transition zones in many cases are not protected areas. And the core area of these sites usually overlap with the national sites. So these sites are also not included in the calculation of the statistics. So for the base map, the base map that is used is the one that combines both terrestrial and the exclusive economic zones, and a 30-meter resolution global shoreline. So this base map is maintained by UNEP WCMC and is used in the calculation of the statistics. However, every country or territory may have their own detailed base map, which is used at national level for calculation of area and the other statistical requirements, especially when they are reporting towards their conservation targets. So let us look at the method of calculating the protected and OECM's coverage. This method will be done practically for national sites, but at the global level, first, it's important to mention that the World Database on Protected Areas is updated every month. So there is a new release every month, and even when you go there and download the data for your country, you will notice that there is a version for September. So there is a September release, and even next month in October, we'll have an October release. So when you are calculating the statistics, first you start with the current release, current monthly release. So for your case, when you shall be doing your national statistics, you have to go and download your current release. Then the second step is that you have to filter and exclude records as per the characteristics that we have just talked about. For example, first you need to go there and exclude all sites that have not reported their status, or those that are proposed sites, and include all those sites that don't meet the protected area definition. For example, the biosphere reserves need to be excluded. So after you have filtered all that, then you have to create a buffer around those protected areas which are reported as points. And I have a formula for that, so we shall be using it. However, of course, buffering points has its own disadvantages, because you can underestimate or either overestimate protected areas. The assumption is that all these protected areas that are submitted are circular, because a buffer will be circular in shape. However, protected areas are not circular. So you'll have what we call underestimations and overestimations. In some cases, for example, you can have what we call, you can have the created cycles around points can cover areas where protected areas don't exist. So in such a case, you'll find that these are overestimations. Or they can also overlap with areas where other protected areas already exist. And in this case, that is an underestimation. And if the underestimation or overestimation occurs, then of course, it introduces some level of inaccuracies in the statistics. So The second, as you continue, the next procedure is that both the polygon and the buffered points are combined in a single layer. So you have to come and merge both layers into one. And once you have merged them into one, the layer is flattened. It is dissolved to eliminate overlaps. So once you eliminate overlaps between designations, you avoid double counting. And the next procedure is that the global protected areas flat layer is intersected with the base map of the world. So you intersect this with the base map of the world, and then the area of each polygon is calculated in square kilometers using geodesic area calculations in WGS 1984. The next procedure is that calculated areas are summed by land, so land, marine, and areas beyond national jurisdiction, what we normally abbreviate as the ABNJ, areas beyond national jurisdictions. These are areas that are in the exclusive economic zones, or economic exclusive zones. So marine and coastal areas are those outlined in the EEZs, and as seen in the section 3. ABJ constitutes international waters outside the 200 nautical mile limits of national jurisdiction. So that's just a clarification. EEZs are part of national jurisdictions, but anything outside 200 nautical miles is an area beyond national jurisdiction. So the terrestrial protected area coverage is calculated by dividing the total area of terrestrial protected areas by the total global terrestrial area, excluding the Antarctica region. So that one will give you now the statistics for the global protected area coverage. The areas above national jurisdiction protected area coverage is calculated by selecting the area where the ISO 3 is the ABNG. ABNG is the areas beyond national jurisdiction. And then marine and coastal protected area coverage is the total global protected area flat coverage, minus the areas beyond national jurisdiction area and the land area. For the OECMs also is calculated in the more or less the same procedure, because first you also start with the latest WDOECMs monthly release, and then a buffer is created around the OECMs reported as points using the reported area. Both polygon and the buffered points layers are combined in a single layer, and where protected areas and OECMs overlap, areas where protected areas and OECMs overlap are erased from the OECMs layer above using the global protected areas flat layer. So this is also to avoid double counting between the OECMs and the protected areas. So the output OECMs layer is flattened, which it's dissolved, and the OECM flat layer is intersected with the base map of the world. The area of each polygon is calculated in square kilometers using geodesic area calculations in the World Geodetic System of 1984. Calculated areas are summed by land and exclusive economic zones. The total protected area and OECM's coverage calculation procedure include, now the terrestrial protected area and OECM coverage is the total area of terrestrial protected areas plus the total area of the terrestrial OECMs divided by the total global terrestrial area excluding Antarctica. And the marine coastal protected area and OECM coverage is the total global protected area dissolved coverage, subtract the areas beyond national jurisdiction, plus the land area, plus the marine exclusive economic zones, OECM's coverage. The areas above national jurisdiction coverage can be calculated, but there are no currently OECMs in this area, and therefore it's not, that statistics is not usually calculated. So the national statistics follow more or less the same procedure, because again you have to start with the latest monthly release of the WDPA, and then you have to go and filter to exclude the records with the above characteristics, what we discussed. Create a buffer around reported areas reported as points using the reported area. Of course, you have to exclude those areas that didn't report the area. And then both polygons and points layers are combined in a single layer, and then the layer is dissolved by country or territory to remove overlaps between designations within countries and territories, and to avoid the double counting. And one thing that you need to note is that when you dissolve overlaps, sometimes because we will be using the ISO 3 code, the overlaps between countries are retained, because we normally don't dissolve spatially, but we dissolve using the ISO 3 code. So we shall be doing this practically, and I want us to do this fast as we proceed to other statistics. So first, let us calculate the protected areas and the OECM's coverage for the countries, and then we can proceed. Remember the first step is to start with the current release of the WDPA. So what we're going to do is that let us go to the Protected Planet website. Go to the Protected Planet website, and once you're there, let us download the data for our country. And because for me, I come from Kenya, I will use Kenya. So how do you download your data for your country? First, click on Explore Protected Areas and OECMs. And then come in the resultant window, click on Countries, then search for your country. Or maybe I can change the country. I've used Kenya before. I can use one of the countries in the southern African region. I'll use Eswatini. So let me use Eswatini. So you can just search for your country and press enter. And once you press enter, the list will be filtered, and you will remain with your country. For example, you can see I have Eswatini, the Kingdom of Eswatini. So in the resultant option, just click on your country. And the reason why I chose Eswatini is that because Eswatini also has OECMs. It is one of the countries that have reported OECMs. So once you click on Eswatini, click on the green button on the top right corner, and then choose File Your Database. Remember, I have said this before, that you can only download data from Protected Planet for non-commercial use. So if you want to use data for commercial use, then we have a website that is provided. There's this option here called IBAT. You go and click on it, and then you'll be guided on how you can access data for commercial use. But for this purpose, because we are using data for non-commercial use, you just come and click on Continue. And then it will be packaged, and you can see it is down there. And very importantly, if you are using this data for any research, please make sure that you cite the source accurately. You can see the way you need to cite. You just copy this text and cite this resource. So for us, we just want to use it for training. I just click on download to download your data. And your data is downloaded. So when you come and click on this, in this folder icon up here, it will show you where your data has been downloaded to. So I want us to first copy the data to your working folder. So I'll copy my data here. Just right click and copy. You can even cut. You can even cut and then go and save it in your folder. My folder is here called JS for conservation. So I come here and I'll look for data. I don't have data here. I can create another folder here for the data sets that I'll need. So what I'll do is that I'll just come here, up here and click on new folder and create a folder called training datasets. Have I created? Not yet. So just click here. Yes, and just call it training datasets. And normally when you are saving your folder, remember not to use either special characters or spaces in your name, because sometimes the software may refuse to pick that, to read the link. So make sure that you either use an underscore or just don't use space inside your name. You can also use simple names. So I have created my folder. I'll paste my data here, just paste it there. And then you can see it is a zipped data, so we can just unzip it. Right click and extract the contents of the folder. And then when you check it, you'll see that it has all the files. I know that by now you already know the contents of a zipped folder that is downloaded from the protected planet. So with this data already downloaded, we can open ArcGIS Pro. Open ArcGIS Pro. For me, I already have it, but for you, you need to open a new window. And then I need you to add it to your map. So to add it to your map, first make sure you are in the Maps tab. Then you can just go and click on Add Data, and then click on Browse. So once you click on Browse, you can just browse now to where you copied your data. In my case, I copied it in the volume disk D. So I'll go to volume disk D. Then let me just sort my folders. Here is my folder. It's called JS for conservation. I'll open it and then scroll down, and I have my training datasets folder. I'll open it, and here is my folder, the one that I copied here. I will still open this, and then open my file geodatabase. And here I have only one layer. Somehow, Eswatini does not have a point layer. So what we will do, we can use Eswatini for just a general calculation, but then we need to go and use another country for point features, because it's very important that we also account for those protected areas that are reported as points. So click on it and just add. Though it's a call, maybe it's a call that we can make to everyone, that we should try as much as possible to map our protected areas. We have learned about the various ways we can map our data spatially. Please use some of the knowledge that we have acquired here to map your protected and conserved areas. Some of the methods are cost effective. They are very cheap. For example, you can use the readily available equipment to just map your protected and conserved areas. Also, there is a lot of support, both financial and technical support out here that if you need, you can get. So with that, I have loaded my layer. Remember, the first procedure was to start with the latest release of the WDPA. In this case, it's the September release, and you can go and confirm even from the folder the data that we have used. Let me just check training datasets. Even in the name, you can see it's called WDPA WDOECM September 2025 Public SWZ. This means that this is the September release of the database. And we are in September. This is the 3rd of September. So I'll switch back to my ArcGIS Pro. And then the second step here is that we need to filter out. We need to filter out data as per the above criteria. So the first thing that you need to do is that only sites that meet the definition of IUCN or CBD definitions of protected area and OECMs are included in the calculation of coverage statistics. So fortunately, all the areas qualify. They qualify to be OECM, to be protected areas and OECMs. The fact that these sites are already in the WDPA means that they meet the definition. Remember, there is a field called the PA definition, where some were given 1 or 0s. These are the sites that are used in the calculation of the statistics. But maybe to be sure that we are working with the right data sets, we can go and just filter out the sites. So how do you go and filter out those sites? I'll show you shortly. Let me just switch back. And this is the one, I want to teach you another method of working with the spatial data here, especially when filtering. We have what we call definition queries that you can apply on your data. So that is what we are going to use for filtering. To apply it, just click on, right-click on your layer in the contents window, just right-click on it, and then click on properties. Once you open the layer properties, on the left side, you can see there is an option called definition query. Just click on it. And then you can see there are no definition queries defined at the moment. But we are going to define a number of these queries, and these queries will apply on our data, especially on the part of filtering the protected areas that don't participate in the calculation of the statistics. So just click on New Definition Query. Just click on it to start defining. So the first criteria is that those sites must meet the definition of an OECM or a protected area, as per the IUCN or CBD definition of protected area and OECM. And as I told you, if a site meets a definition, normally it is given a 1 if it meets the definition of a protected area, or it's given a 0 when it meets the definition of OECM. Any other value is not considered here at the PA definition. So if you come to the PA definition, you can say PA definition is equal to, then you pick 1. So what it will do is that it will pick those sites that meet the definition of 1. And then you can add a clause and say, or PA definition is equal to 0. This is our first query. You can click on apply. First, we had 22 sites. So we click on apply and let's see whether There are still 22. Click on apply, then OK, and then come and open the attribute table to just check how many sites we have. We have 23, which means all of them meet the definition of a protected area or OECM. So if all of them do, then we don't need to even have that definition query. So you can even just go back to the properties and delete it. Click on the X there to remove the definition query. Click on yes, and click on OK. So we have removed that definition query. We go to the second criteria, which says that for example, for now we are not, we don't have accessibility to those protected areas which have been requested to be private. So we will just use the layer that we have downloaded for the purpose of this training. But if in your country you have maybe you publish your protected areas and you have some that you don't publish because of certain confidentiality issues, then when you are doing the calculations, just make sure that you use that layer in the calculation of the statistics. Then we also go to the next criteria. The UNESCO Man and Biosphere Reserve sites reported to the WDPA are also excluded on the basis that the MAB sites currently in the WDPA include buffer and transition zones. That is, in many cases, these sites are not protected areas. So first, we are calculating protected areas. Then we shall go to the OECM. So for the protected areas in this case, let us just filter out this layer for Fesotini to remove all the biosphere reserves. So how do we go about it? Right, click on the layer, go to the properties, click on the definition query, then new definition query. And how do you identify whether a site is a biosphere reserve or not? It is through the designation. So you pick designation. Designation is equal to, so in this case, because we're going to exclude biosphere reserves, we'll say designation is not equal to, and then you come and pick biosphere reserves. So you click on UNESCO MAB biosphere reserves and click on apply. So what will happen here is that these sites will be removed from the layer. So if you come and now open the attribute table, you should have fewer sites. You can see we had 23 sites and now we have 22, which means biosphere and MAB reserves have been removed. Then we can go back to the third criteria, which says that I think let's go. And I think we should be using the method for the national statistics. So let me just scroll down to the national statistics. These are global. Here. So first, filter out those areas to exclude records with the characteristics listed above. So these characteristics also include proposed areas that are, or sites that are in the proposed status. So for example, let me just scroll up to this condition. The condition is up here. Condition is somewhere here. That proposed protected areas and those whose status have not been reported are excluded from the calculation. So we need to remove those sites. Proposed and those whose status have not been reported. So to do that, we switch back there, and then you go back to our definition query. You right-click on your layer, go to Properties, and edit your definition query, and then add a clause. And the first clause is that designation is not equal to. So the second condition needs to have, so you have two kinds of operators here. You have and then you have or. And means that for these conditions that you are giving, you are defining that data sets or the data that will remain must meet all the conditions. But if you put or, what you are saying is that the data that meets any of the condition should appear. So for us, we want to make it mandatory that a site must not be an urban biosphere reserve, and a site must not be a proposed site. So you can come here and click on this arrow and pick the status field. So go and pick status. The status is equal to. So because we don't want to get those sites that are proposed, pick is not equal to. Is not equal to proposed. And then apply. And then click on OK. And then let us see one site has been removed. So far we have 21, but we had 23. Then you go and also remove those that have not been reported. So you go back to the definition query, right click on your layer, go to Properties, edit your definition query, add a clause, and the status sorry, here it is not equal to. Fortunately enough, Eswatini has reported all the status of all their protected areas, and therefore you may not see not reported under the definition query. So we shall just remove this, and then go and look for the other condition. Sites submitted as points with no reported area are also excluded. Fortunate enough, Eswatini has mapped all their protected areas, and therefore all the protected areas are polygons. And I have up to there, we have filtered all the sites that we needed to filter. All the sites that we needed to filter, we have removed this or everything. Good. So we go to the second condition now. Let me just scroll down the next step. So after you have done that, a buffer is created around the protected areas reported as points. As I've told you, Eswatini has mapped all their protected areas. All of them are polygons. Then the third one is that both polygons and the buffered points layers are combined in a single layer. So this step shall be skipped because the Eswatini does not have a point layer. Then the fifth procedure is that the layer above is flattened, dissolved by country or territory to remove overlaps. So we shall skip from step number 2 to step number 6. So what we're going to do is that we're going to dissolve the protected areas in Eswatini using their country or territory. Remember, in the WDPA, the country identifier is the ISO 3 code. So we shall use the ISO 3 code to dissolve the protected areas of Eswatini. How do we do that? Switch back to the WDPA. First, you can click on OK to apply the definition query. And then once you click on OK, we can now come here and you can close the table as well. Just close the table. And then we need to dissolve these protected areas. And as you can see, let me show you an overlap here. We have some protected areas which might be overlapping. We may have some protected areas which might be overlapping. So to ensure that you don't double count protected areas, you need to, we are going to dissolve so that we get one continuous area for all the protected areas. So what we're going to do is that I want you to go and click on Analysis tab up there, and then open the tools. And then we are going to use a tool called Dissolve. Just type Dissolve, and then there is the first tool that comes with this Dissolve tool under the data management tools. This is the tool that we need to use. So just click on it. And then the input layer, you click on the arrow and just choose the layer for Eswatini. And then for the output feature class, you can use the default one. It has a dissolve, _dissolve at the end. And very importantly, what we need to do now is that we need to select the dissolve field. As I told you, we will use the ISO 3 code to dissolve this data. So scroll down and choose ISO 3. And then statistics field. So at the end of it, we need to retain the area. So we shall calculate the area for the whole, for the country. So we can pick, click on it and pick GIS area. Remember, this is not mandatory, but we can just retain it as a field that we shall use. We will calculate eventually, but for now, because this one will give us a sum, but data value will be wrong. The value will be wrong, so we can also decide not to include a statistics field. But we shall create a field for area. So you can see it's asking whether you want to create multi-part features, and check this option here, and then just click on Run. Once you run this operation, you can see we have two layers. One is a dissolved layer, another one is the original layer. When you uncheck the dissolved layer, you can see there are boundaries in between protected areas that overlap. But when the second layer, which is a dissolved one, when you dissolve, it gives you one layer that has no boundaries in between. So if there was maybe an underlying polygon on one of the polygons, it has been dissolved only to show an area. And you can see it here. This means there was a polygon here. You can see this line here. It shows that there was a polygon here that has been dissolved. So with this one here, we can now proceed and calculate the coverage of Eswatini. How can we do that? We can first open the attribute table. And you can see only a few of these attributes have been left for Eswatini. Only a few. Actually, we need to get one dissolved layer. So let me check this option here. Put one here and then just create one that has multi-part here. So let's see. Good, this is what we need to see. So you only need to see one polygon as opposed to the many polygons that we got here. This one, you need to create multi-part features of one polygon, which we unchecked, and we ended up having many polygons. So we are discarding the previous dissolve layer. You can just remove it from your map. Right click on it and click on remove. Then let us remain with the dissolve one layer. So in this dissolve one layer, we can be able to come and calculate the area in square kilometers for Eswatini. And it will also give us an opportunity to go and compare with the area that we have for Eswatini. So we can add a field for this layer, and I know that you are taught how to add a field. You click on add here, on this button here to add. And then you can call it area, national area. National, let us call it country, or national area is okay. National area is okay. I remember there is also a limitation on the number of the characters per field. So the shorter you can be, the better. So you can call it just area, and maybe to be specific, SWZ to mean it's a national area. But for the alias, you can type anything. You can just call it national area. National area. But you can use even, as I told you, spaces are not good in computing, so use an underscore instead. And then we have the data type. And I want to speak a bit about data type. We have long and short. Long refers to integers. So the long integer will allow you to enter a longer character, so a longer numeric value. A short character will only allow you to have a few numbers. So what it means that if you know that you're going to get a value that is very lengthy, then you can use long as the data type. Remember, these are integers. Integers are not decimals. So if you have data that is in decimal format, you cannot use long or use short. However, for an area which is given in square kilometers, this area can come in form of decimals. And therefore, long or short cannot be used as data types. So you can only use two types of data types. You can use double or what we call float. So double refers to a data type that allows decimal values. But double refers to a data type that allows decimal values that is longer than, it allows more decimal values than the float. So if you know that you will have longer decimal values, you can use double instead of float. So, however, double consumes more space than the float. So it is more accurate because it gives you more decimals, but it consumes more space. So if you are more, you need to conserve space, you need to preserve your space, then you can use the float. So in our case, we're going to use double because it's more, sorry, what have I taken? Choose the double because it's more accurate and we want to get accurate data. So with that, after you have done everything, I just want to close this so that it gives us space. If you have done everything, you can go up there to the edit, to the fields tab and just click on save. Click on save. And then you can even close these fields window. And once you click on the field, when you close, you can see you have your national area field has been added. So we will be calculating this area. We will calculate this area, and to calculate it, I need you to come and, or let us check the next procedure first before we just go ahead. So we skipped from procedure number 2 to procedure number 6. We skipped from procedure number 2 to procedure number 6. And then there is something on the transboundary sites that are shared between two or more countries. So transboundary sites, which are shared between two countries, what we call maybe transboundary sites or TFCAs, these sites are split geographically according to which part of the protected area is located. And when this part is, this protected area is split, the base map is used. Because we don't have a base map at the moment, we will only use the ISO 3 the way we have used it, and just compare the results with the results we have in the WDPA. The value should be closer to each other. This one will not apply for now. So we can go back to the ArcGIS Pro and calculate the value for this area. So to calculate the value, you just click on the area, on national area, then click on calculate geometry. Allow it to open the geometry, the calculate geometry dialog. And then we are calculating an area, a geodesic area, so click on area geodesic. And then for the units, we are working with the square kilometers, so pick square kilometers. And then for the coordinate system, come and pick pick the coordinate system. Normally we use projected coordinate system. Come to the world and pick World Geodetic System of 1984, World Marketer. World Marketer, and then click on OK. And then click on Apply, then OK. So once you do that, you can see it has given us a value. This value is in square kilometers. So what we need to do is that we need to calculate the coverage of Eswatini. And how do you go about it? We are going to create another field. So come and click on Add here. And let us call this field coverage, percentage coverage. Let us call it coverage. Let us call it coverage. And still, let us use a double. A float is okay because a percentage, you don't want to have a very long percentage. So a float is just okay. Pick float, and then click on save up there. And then you can close this fields window. And you can see the coverage is added. So for this one, we are going to calculate, but before we do this, I want to switch back to the web so that we get the exact area of Eswatini. So I just open the browser and search for. Actually, you don't need to search. We are here for Eswatini. Eswatini, in the WDPA, it will give you the total area of Eswatini. Eswatini is a landlocked country, and therefore it does not have the marine protected area coverage. So we shall just be working with the one area, the terrestrial and inland water protected area coverage. And the total land area of Eswatini is 17,370 square kilometers. 17,370 square kilometers. So we'll pick this value. We shall be using these values. Just take note of it. I'll come back for it, but let me just switch back to ArcGIS Online. Right-click on coverage, then click on calculate field. You can choose any language that you want. If you want to use a CAD, you can just pick a CAD and then come and calculate. So we shall be using the national area. So the formula is actually the national area divided by it is actually the national area for the protected and conserved areas divided by the total area of the country. So double click on national area, then pick an operator, divide by, and then because we don't have the total area as a value in our layer, we will pick it. We will pick it from the WDPA. So when you switch back, it is 17,370. So divide by 17,370. So remember, what you will get here will be a fraction, and therefore to get a percentage, you have to multiply by 100. So you put everything here in brackets. Put everything in brackets, and then multiply by 100. So with that, I know that we will not get the exact area, but it should be closer to what is on the WDPA. So click on apply, and then OK. So the coverage of Eswatini, according to our calculation, is 4.698 percent. It's 4.698%. So we can go and compare with the other value. And on the protected planet, it's 4.23%. And maybe where we have gotten, or where there is a discrepancy, is on the transboundary protected areas. We don't have a base map layer for determining what belongs to Eswatini and what belongs to the other countries, other neighboring countries. So maybe one remaining thing is that maybe I can show you very fast on how to also create an area around the point features. We have used Eswatini before for this exercise, but for a country that has points, how do you go about it? So what I'll do is that I will just close this, and then I'll click on Insert, and then click on New Map so that we don't interfere with what we did for Eswatini. So I just want to show you very fast how you can do this. You can calculate an area around a point feature and use it for reporting. So what we are going to do is that let us use a country like Kenya. Sorry, I'll close this and then bring this up here. Bring it up here so that it does not interfere with their work. So we can use Kenya because Kenya has points and polygons. So you can come and click on the Map tab and then add data. And in this case, you just browse and add the Kenyan data. I don't know whether you already have it in your computer, but for me, I have it somewhere, so I just want to move it from a downloads folder to my working folder. So I have it here as Kenya, September 2025. I'll just copy and then go and paste it in my folder somewhere here. I'll paste it somewhere here. Under the data sets, training data sets, I'll have it here, and just first rename and remove the one just be in front of it. And then I can extract to that. So I have data for Kenya, so I'll switch back to the ArcGIS Pro, then just go to my training datasets folder and click on this refresh button. If you have added your data to a folder and you can't see it, you can click on refresh button to just refresh the folder so that you can see what you have added. Here I have the Kenyan data. I can open my file here database and add the 2 layers. Add the 2 layers. And in this situation, I just want to start with the points layer. So allow me to just switch off the polygons layer so that I remain with the point layer. And then for the point layer, we will also perform the filters that we need to. So we will open you need to open the properties, the layer properties dialog, define a query. The first query, of course, is on the status. You go to status. Status is not equal to, number 1, proposed. So, but maybe for you to appreciate this, first we need to check how many features do we have under this point layer. So when you check there, you can see we have 50 features. So when we perform our definition query, the number should reduce to something less than 50. So let me close this and then just perform the definition query again. Go to properties, define the query, where status is not equal to proposed. And then you click on apply. And then OK. So when you click on OK, the number of points you should reduce. So when you come to attribute table, you can see we have a whole 13 points have been removed. We can go back, right click on it again, go to properties again. Then we remove, go and edit the query, add a clause, and designation is not equal to UNESCO Biosphere Reserves. Apply, OK. You can see they have reduced from 37 to 31. So about 19 points have already been removed. And then for those areas that have not reported their area, and a reported area here will still be removed. So you can still go there. Right-click. Go to properties. Edit your definition query. Add a clause. And reported area. So go to reported area. It's denoted as a rep area. Is not equal to zero. So here you'll get values. Let me see. Perhaps here we can use a different. Operator. Is less than or equal to. Then you just type a 0. Just type a 0. So what it will do is that anything that is less than or equal to 0 will not be used. So with that defined, you can click on apply, and then apply again. Okay. Okay. We can define our query. I think the last one has removed everything and is greater or equal to 0. Is greater than or equal to 0. Only those that are greater or equal to 0 are greater than 0 are greater than 0. Is greater than 0. So the not equal one is not included. It's greater than 0. Then you click on apply, then OK. And our 31 points reappear. So what we shall do is that I think we have applied all the requirements to this layer. I don't think there's anything that we have. Good. So I think we have applied everything. So we can just close it. Then we can go and create an area around this. But before we create an area, I want us to open the attribute table. So before you create an area around a point, you need what we call a radius. And this is the basic mathematics that maybe you already know. And for our points, we only have the reported area. But using the reported area, we can still be able to get the radius. So, of course, there's a formula about it, a formula that you can use. You can go and Google, it is all over. But I have it already, so I will just use it to calculate the radius. So first we need to create a field called radius. Click on add. And add a field called radius. Add a field called radius. The field can have a data type of either a double or a float. Let us use a double so that we are very accurate with our radius. And then allow null, highlight, blah, blah. Okay, good. So we can have a radius which is a double. And just come and click on save. Click on save. And then we can even, no, we can't close. So when you click on save, you can see the radius has been added here. You can move it. You can move it this direction. You can move it so that we see it very well. It's somewhere here. So if you want to move around, assuming that you want to move around your fields to rearrange them, you can still be able to rearrange your fields and take your field to where you want. You can place it near the reported area because you shall be using the reported area. So how do you go about this? And remember, this particular radius that you're calculating, we need to calculate this radius in meters. Because as much as the reported area is in kilometers, when we shall be calculating a buffer around our points, the software will base the calculations on the coordinate systems. And we don't have a coordinate system in kilometers, so we shall be calculating our radius in meters so that eventually, when we calculate, we create a buffer around our points, the buffer will not be, we'll get almost the same area as the reported area. So to do that, I want us to right-click on radius, and then click on calculate field. And then I want you to switch back to the presentation and just scroll so that we go and copy the mathematical expression that is in there. So copy this mathematical expression the way it is, and then come and paste. Switch back to ArcGIS Pro. Make sure that the expression type is Python because this is a Python expression, and paste it there. Paste it there without space. And then just click on apply, and then OK. Apply and then OK. And you have your radius in meters. So this radius is in meters. This radius is in meters. Then we shall use this to create a buffer around our points. So for us to create a buffer around our points, go and click on Analysis, then open the tools, and then come and type buffer. Type buffer. We are creating a buffer using the analysis tools. So just click on the buffer. And then the input features, in this case, it is the points layer. You're working with the points layer. And you use the filtered records. We are only using the filtered records. The output feature class, you can use the default. It's okay, use the default. The distance value. So you can have one value for all the points, and all the points will be buffered with the value that we will give it. And as I told you, use meters when giving a value. But here we want to use a linear, we want to use a field. So for example, we don't want to use a linear unit. We are using a field for this. So click on the arrow and pick the field here. Click a field. And then it will allow you to pick the field that you want to use. So down here, you can come and now select radius. Scroll down and pick radius. And then we have the method. If you remember what I mentioned is that we have geodesic and the planar method. The geodesic method preserves the shape of the features. And the planar methods, of course, uses the flat earth to calculate the area. Geodesic is more accurate in this case, so just pick geodesic. And the dissolve type, down here, it asks you whether you want to dissolve the buffers that you're going to create. And to minimize the work that we're going to do, we can dissolve the buffer. Let us dissolve all the features, because eventually we will need to dissolve. So you can click on dissolve all output features. Or maybe before we dissolve, maybe for the purpose of confirming whether the features we have created are accurate, we can leave it the way it is, no dissolve. And then later on we will dissolve. So just leave it the way it is and click on run. And once you run, you can see, you can just close this. You can see that there are polygons created around the points. If you're keen enough, you can see we have these polygons here. Let me just close this so that you can see very well. We have polygons created around the points. We have polygons created around the points, according to the reported area. So what we're going, and you can see here we have polygons overlapping each other. Here you can see we have polygons overlapping each other. And the dissolving allows us to avoid double counting for such a kind of a situation. Because if you come and sum these two, then you'll get an area that is bigger than what is supposed to be. Though there is also what we call underestimation and overestimation, especially if the bigger part of this polygon was out here, then we can have what we call, what we have currently is an underestimation. But if a bigger part was inside, then what we have currently can be an overestimation. So what we're going to do is that we want to confirm whether the area is near what we have, near the area that was reported. So if you want to validate the method, if you want to validate the method that you have used to create this one, or the radius, you can just come and open this buffer layer, right click on it and open the table of attributes. And maybe we can create another field and call it estimated area. So we can call it EST underscore area. And that is the area that we want to confirm. Use it to confirm whether our radius was accurate or not. And then we can make this a double, make the data type a double, then just save. So once you save, we can switch back to our table of attributes. And then let us calculate the area. So in the estimated area, just right click on it, calculate geometry, and then pick area, geodesic. But then for the unit, we pick square kilometers because we want to compare the reported area and the estimated area. And for the coordinate system, we can click on this, go to projected coordinate system, world, and then pick the world, the WGS 1984 world marketer. WGS 1984 world marketer. And then click on OK. And then click on apply, then OK. Apply, then OK. And what I want us to do is want us to compare this area with the one that was reported. I want us to compare this area with the one that was reported. So you can see field by field. The first one is 314.69. What we have calculated is 314.48. The second is the 108.8. The one that we have is 108.77. So you can see our method or our radius was not very far from the accurate radius. So with this one, I think we have just validated our radius, and we can just continue with dissolving our polygons. So how do you dissolve your polygons here? Let me just close this. Let me close this and show you how we are going to dissolve. So to dissolve our area, you come and click on analysis and open the tools, and then search for the dissolve tool. Search for the dissolve tool, and we are using the data management dissolve tool. Click on it, double click on it, come and choose the input features. In this case, the input features is the buffer zone, the buffer area. The output feature class, you can leave it the way it is, the dissolve. The dissolve field, as I told you, of course, it is the ISO 3. Then we don't need any statistical fields. We are creating a multi-part features, and just click on run to dissolve. So when you dissolve, you can see we have a dissolve layer is here. Open the attribute table. And we can now create a field for area. Create a field for area, click on add, then click on the field for area. You can create the name, call it point area collect point area, just for guidance, to guide us that is the area that we have created around the point layer. And then let us use a double as the data type. So just use double, and then click on save. Click on save, and then let us switch back to our table of attributes and calculate the area. Right click on it, calculate geometry. Calculate geometry. Use the point area. The property is area geodesic. The coordinate system, as I told you, the areas unit is the square kilometers. And then the coordinate system is WGS 1984, world marketer. So just go to projected, then go to world, then WGS 1984, world marketer, then click on OK. Then click on apply, then OK. Apply, then OK. And it should give you an area. So with this one, in fact, we were not supposed to create an area, but we have just created an area so that you see how you can calculate an area from the point features. So in our next session, I'll be also showing you how to now combine the flattened layer, the dissolved point layer with the dissolved polygon layer, and how to get the area, the total area of the country, and how now to calculate the percentage coverage of the protected areas of a country for reporting towards target 3. Up to there, I want to thank you for the session. If you have any question, please go to the community. We will answer your questions there. Thank you.